has enormous potential to inspire young students to go into careers in math and science, not just in space, but in math and science overall. And I think we need to work very hard to find creative ways to engage those students in ways that are going to be captivating for them. I recently had a fascinating experience. I gave a talk to 20,000 young middle school and high school students, mostly from underprivileged school districts in Detroit. I did it at Ford Field where the Detroit Lions played. I was lined up on the 10-yard line between the hash marks with the end zone filled with middle school students and showing pictures that had come down from Mars 4 hours before on the Jumbotron screen. They were captivated. They get turned on by this. And if we can take what we do and the passion that we all feel for what we do in space and we can find creative ways to reach those people, it's an enormous resource out there. It really is.
I agree very much with my colleagues on this topic, but let me add one other nuance here and an issue that we face, and that is that the timetables today are getting to be so long for these space missions, a decade or more, that it's difficult to attract students into these programs because the timetable for building these instruments is well beyond the typical tenure of a student either at undergraduate or graduate level. And so they don't have a chance to fly these missions, if you will, while they're in school. So we have a problem that it's making it difficult to attract new instrumentalists who will build the next generation of spacecraft, sensors or imagers. And it's something that we need to face. I think Dr. Stern is helping by re-implementing. We almost drove the balloon and the rocket program out of existence. And so this is very helpful in that regard, but we really need to do much more.
Thank the panel for some really important insights into this crucial area of how do we recruit young people into these important fields, and then how do we retain them and give them a sense that this is very worthwhile. The chair recognizes again the gentleman from California for 5 minutes.
I would just note that unless our children have a good foundation in science and mathematics, that you're not going to be able to recruit them later on. And let me just note that all the hearings that I've had, especially yesterday with Gates, it's very clear that there is such a hesitation to confront the political problem of permitting science and mathematics teachers to receive more pay than the teachers of other subjects. And a pay differential is the fundamental issue that's going to either make us successful in giving these fundamental skills or not, because you've got dozens of people who want to teach English literature and history, and they frankly don't, for every one person that you can maybe attract to teach science and mathematics. And the science and mathematics people can make a lot more money doing something else rather than teaching. So we need to pay them more money. And there was a movie called, and I remember they said it was about a baseball diamond. They said, "Build it and they will come." Well, pay more money and they will come. And unfortunately, there's a major political impasse in that certain political people have relied on unions and the educational unions, which would rather hold America back than give up the right to have every teacher in every subject has to be paid exactly the same amount of money. That's the fundamental problem we face there. I was also mentioned someone seeing the light at the end of the tunnel. I hope when they're looking through a telescope, the light at the end of the tunnel isn't a near-Earth object headed in our direction. And I think someday it will be. And I understand there's even been some near-Earth objects that have, they come so infrequently, but there happened to have been one just a short while ago that came between the Earth and the Moon. That close, we didn't even know it was there until after it had gone by. And I think that it's worth our while to be able to look out. And by the way, that's also something that we actually passed some legislation. It gives awards to young people who, if they look into the skies and discover some near-Earth object, we give them an award. I think a Pete Conrad Award that I authored the bill that permits this and gives this award every year to a young person that discovers some object. So that's a good way of getting young people involved as well. Let me ask, there was mention about earlier, and I believe it was you that was talking about the discovery of planets, outer planets or something that NASA's doing?
Congressman Rohrbacher, I think exoplanets, is that
Yes.
what you're referring to, around other star systems?
Yeah, how much are we spending discovering these extra planets?
Well, I have to I'd have to turn to Dr. Stern because I don't know those numbers off the top of my head, but we've got a new mission which is going to be launched next year called Kepler that is going to be dedicated to looking for new stars. Right now, based on ground-based observations, over 250 planets are known to now exist around other star systems.
The question that I need to answer here is, why are we willing to, this is obviously an expensive proposition, why are we willing to launch a new program that's going to cost money to find out about planets from distant stars when we're not willing to spend even more than $3 million a year trying to find near-Earth objects that may or may not hit the Earth and kill millions of people?
I think that's for me.
Yes.
Well, let me say that in executing our exoplanets program, we're following the recommendations of the National Academy. It's a very exciting program. We have a number of spacecraft that we're turning to that task, and we're building Kepler.
How much is that going to
Looking
cost?
forward to future programs.
How much will that cost?
Well, those missions are typically in the Kepler cost class, and they're $600–800 million.
Now, Mr. Chairman, let's just note, $600–800 million, and we're quibbling over whether or not we're going to really have a program that can really take care of charting all of the near-Earth objects in a very quick time, just to see if one of them might hit the Earth, and quibbling over a $5 million telescope, which may, and I'm going to look into this, which may or may not play an essential role. If it doesn't play an essential role, I'm going to take that back, and I'll call my friends at Cornell and tell them I got the wrong information last time we held a hearing. I do seem to remember, Mr. Chairman, last time we held a hearing, all of the witnesses told us how vital this telescope was, but to spend hundreds of millions of dollars to find a planet in distant stars and not be willing to, it just seems
Mr. Rohrbacher, if I may, I'd like
Sure.
to tell you about our NEO program, because it's an exciting program as well.
How many? It's a $3 million program.
Well,
is it not?
it's commonly referred to as a $3 million program. In fact, because we were lagging in our goal that the Congress set to finish by the end of 2008,
right,
detecting 90% of all the kilometer-class potentially hazardous objects near the Earth, I actually took some of my discretionary funds and helped that program along this year. So it's actually be funded at a little bit higher level than that. But I want to also point out that's not the only way that we study near-Earth asteroids. We have programs in fundamental research in our Planetary Science Division. We've flown a mission to orbit and then land on a near-Earth asteroid
I was there when they did, yes,
called
great.
NEAR. You're probably familiar with that mission.
Sure,
I think
terrific.
its cost level was several $100 million. I think it's about $250 million. We have a mission on its way, although not to a near-Earth asteroid, to orbit two of the largest asteroids in the asteroid belt. We have a whole variety of programs that address the nature of asteroids, their composition, their structure. This all helps inform us about the near-Earth asteroid problem in one way or another, and we are doing the program that the Congress asked us to do, and I expect us to meet that goal by the end of 2008.
Very good answer. Thank you.
Thank you, gentleman from California. I want to recognize the gentleman from Florida for a comment.
Yes, I'll be brief, and then I know the chairman has some questions, but I'll be done for the day after this. I have a big interest in the near-Earth object issue as well. I'd note a couple things. Number one, some scientists believe 64 million years or so, again, dinosaurs and other entities went extinct around the planet because of a near-Earth object actually colliding. We actually had a big one, I think, in 1908 in Siberia that would have been catastrophic. So these things do occur, and I think that Congressman Rohrbacher's concerns are genuine. I would point out that I think, if I remember the testimony